Hello Internet! Today I present the second video in the series Blender and 3D Printing. In the first part we created a Blender template to support the 3D design process for 3D printing. Therefore we have set the measurement system in Blender, configured the settings of the display grid and created a print volume model of a 3D printer to support the 3D design process. To give you something to start with, I will provide a download link to the template with the basic settings in the descriptions of this video. In this part of the tutorial, we will create a coffee cup coaster using the Blender 3D design software. I would like to keep the video short and simple, creating this 3D object and print it on my 3D printer. In doing so, I divide the design process into a few individual steps to define a simple production pipeline workflow. The process will become more complex with the upcoming tutorials. Let's have a look onto the design phase. In the design phase, there are a few points to watch for, as there are the design target definition to define what we are going to design, the design requirements like functional and aesthetic requirements, and also overall conditions we have to obey like material properties or chemical properties. There is a huge amount of coffee cup coaster designs out there. Looking at the examples can be a starting point to create your own design. The design of our coaster will look more or less like a saucer or a plate. You should get a round edge so that no liquids can run on the table, and you should have a thin bottom. In this video we will start with a simple design and make it step by step more complex in the coming videos. For example, we can extend the design with lettering, ornaments or special features. For a first draft we can use the grease pencil in Blender and simply capture our idea in a small outline sketch. Therefore I created a new Blender file, delete the default cube, make sure the cursor is on the same level as the display grid, so you can use Shift S and then the option cursor to center. Go into the top view and use the grease pencil to outline your sketch. Therefore I use the continuous drawing mode. Make sure the Z-axis is locked because we only want to have a two-dimensional sketch, and use the drawing tool to outline your sketch. Our coaster will look more or less like a saucer or a plate. You should get a round edge so that no liquids can run on the table. It has a round shape. This is just a very rough sketch of what we're going to do. There should be an edge which is a little bit higher than the bottom. There should be a thin bottom here, a thin bottom layer, surrounded by a rounded edge. So my expectation is that I will use a torus object for this kind of round edge, and then let's see, we'll create some faces to create the bottom layer. Now we can start to model our coffee cup coaster object. As a starting point, we use the Blender file that I created in my last video. The download link to the file is provided in the description of the video. we have to position the 3D cursor in the center of the display grid. Therefore, I use the Shift S key combination, cursor to center. Looking at our sketch, we see that our coffee cup coaster object is composed of other basic geometric shapes, in our case a torus. Therefore, let's add a torus object into our 3D scene as a starting point. Add the mesh object, select the torus. Right afterwards you inserted the torus into the 3D scene. You need to configure the torus settings. Go into this little dialog that appeared and change the major radius and minor radius. My coffee cup has a diameter of 8.5 centimeters. So I don't want to have the coffee cup coaster too big, because I want to have it on my desk, and always there is not much space on my desk. Therefore, I set the major radius to 5 centimeters, which is 50 millimeters, and the minor radius for the round edge to 5 millimeters. Now we can continue to create the bottom of the coffee cup coaster. Therefore, I zoom in with the plus key on the numpad, switch into the edit mode, and what we're going to do is we want to get rid of the faces. For example, those faces. We can use the loop select functionality. Therefore, I'm pushing the Alt key, and then we have to go to the vertical edge. Just click on the vertical edge, hold the Alt key pressed, and then you select the complete faces in this row. And we can delete the faces here, and we will also select this row of faces. Again, press the Alt key, go to the vertical edge, to one of the vertical edges, right mouse button click, and then you loop select the whole row and delete faces. Okay. Now we need the bottom layer. Therefore, we switch into the vertex select mode. We're still in the edit mode, and here use the vertex select mode. Push the Alt key and the right mouse button. Be careful, you need to have the vertices right at this corner. So now I selected all the vertices in the row using the loop select function. Now I can go into the mesh, vertices, merge, and use add center as the option. Voila! Now we have a bottom layer, but still our object is not watertight. Therefore, you have to do the same thing with the other row. Push the Alt key, use the right mouse button, select one of the vertices, and again go into the mesh, vertices, merge, and use the add center option. Now I will do some modifications on our object. The first thing is I will change the origin of the object. Therefore I go into the object mode and switch back in edit mode, selecting this center vertex and move the cursor to the selection. Go back in the object mode, into the object menu, and set origin to 3D cursor. Now we can change the location to 0 set, and voila, my object is on the top of the grid floor. The object is still a little bit thick, so let's scale it on the Z axis, still in object mode. Use the S key for scale and the Z key for the Z axis and just squish it a little bit. So maybe that is enough. Let's see. From the side it looks good. If you want to make sure you have the right dimensions and you want to measure your object during the design process, during the modeling process, then there is an add-on which is very helpful, is the Measureit add-on. Just go into the user preferences, add-ons, and type in measure, and you should already see the Measureit add-on. If you don't have it in your installation, you can download it. I will provide a download link in the description of the video. It's very easy to install, and the installation guide, or at least the installation instruction, is part of the download of the Measureit add-on. I can provide a short example how the Measureit add-on works. Therefore we switch into the edit mode, selecting two of our vertices. Make sure you're in the vertex select mode in edit mode by pushing this button here. So select one vertex, push the shift key and the right mouse button to select another vertex, and then we can go into the display tab. There are the different dialogues of the Measureit add-on, and we want to create a segment, a measurement between those vertices, and push show to show the measurement. Currently the measurement is shown in blue color and 0.09 meters. If you want to have the measurement unit in millimeters, for example, you can change this. In the properties panel, just go to the Measureit properties. Here they are. Measureit. Here we have several options to change the visualization of the Measureit add-on. Therefore we can change the measurement unit to millimeters. We can also change colors, for example to red. And there's a lot more we can change, but it's out of scope for this video. I want to do a slightly modification. I want to lower this surface here. Therefore I do a loop select on the vertices. I'm in edit mode and in vertex select mode, and I do a loop select on the vertices. Okay, in that way. So pushing the Alt key and the right mouse button and click on the vertex should do a loop select of all the vertices in that row, like in my example. And then I just want to lower this surface a little bit. In case a fluid is spilled, nothing should come onto the table. Now we will have a last look on our object using the wireframe mode. Have a detailed look on our object. So the object is watertight, it has no holes, no gaps. From my point of view, it looks very good. It has no inner geometry and it has no faces that are side by side, and there are also no duplicate vertices. So it should be printable. We should not have any problems with it. So therefore we go back into the solid mode and save it as it is. Switch into the object mode. Select the object. Make sure the object is the only object that is selected in the 3D scene. Now we can export the object. We made sure that the object is selected. No other object is selected. We have the STL export add-on activated. So you can make sure, if you look at the user preferences, type in STL and you see the import export STL format add-on. This needs to be activated. Select the model you want to export. Go into open the file menu. Go into export. Use STL as the export format. We select selection only. We're using the measurement units from the scene. And in case there are any modifiers, we want the modifiers to be applied. Leave all other properties in their default state and save the STL file to a folder of your choice. In my case, I will create an STL folder and save the file into that folder. After we have saved the Blender model in STL format, we can prepare it for printing. Next up, that 3D model we have created needs to be sliced. What means slicing? For slicing, we need a dedicated slicing software. In my case, I use CURA version 3. I open the STL file, and here is a coffee cup coaster, ready for slicing. I can zoom in a little bit. Slicing a 3D model effectively translates a 3D drawing into something that a 3D printer can understand and print. To make the slicing visible, I can start the slicing calculation in CURA by pushing the Prepare button. Using the layer view, we can visualize the slicing results. Since the video has become quite long again, I will explain the slicing and printing process in the next video. In the current video, I introduced a first workflow to create a simple model for 3D printing. We have designed a model that is following our design guidelines and used the appropriate add-ons in Blender to support our process. In the upcoming episodes, I would like to discuss the design process in more detail. I want to further expand our 3D model, make it more complex using Blender's creative tools. If you liked the video, please do not forget to give it a thumbs up. I'm looking forward to more episodes on 3D printing and Blender. Additionally, I added a time-lapse video of the print on the Anycubic Mega i3 printer. Have a good time and see you in the next video.